we go. Have the circuit all built now. Kind of hard to see on this crappy camera, but let me open my function generator, oscilloscope, and the digital multimeter real quick. And let me see what I'm supposed to do. Go. Measure the voltage across the 6.8 kilo ohm collector resistor. Record this value. Okay, cool. Alright, so we're going to be measuring. What is it? Voltage? Voltage, okay. DC voltage. Assuming it's in a low range, so I'm going to start with 2 volts. Got my red probe hooked up to voltage and my black probe hooked up to common ground. There we go. 13.85 volts. Oops, 13.85 volts. And then, okay, DC current, so I'm going to switch my red probe to the current. Change this to measure, I'm going to guess it's in the 200 milliamp region. Go, you got 30.7 milliamps. Oh, I'm measuring by putting the probes on either lead of the resistor as well. All right, function generator time. Just get those out of here. So function generator. Nope, wrong thing. Set it up to be a 5 kilohertz sine wave. And run it, so I'm guessing just 1 voltage peak to peak. Use your 2 scope channels to observe both V in and V out. Remove the load resistor. Since you'll be again with an unloaded voltage measurement. Adjust the FGen amplitude so that the output is not clipping. Oh, okay. Set up peak-to-peak voltage measurements for both 2 scopes. Record the 2 voltage peak-to-peak measurements here and show your screen. Say I measured. Okay. Shall run that. Go to my oscilloscope. And let me set up my probes. So I'm going to put both negative to ground. Both probes. And then I'm going to put 0 positive at FGen. Remove my load resistor. Put 1 positive at output. And run. That's... Whoa. There we go. Ah, it's so confusing. Edge. There we go. Okay, so redoing this last part because I had the probes switched, but I have my one channel 1, I mean, set up as my output and my channel 0 set up as my input. And I'm going to run a 5 kilohertz function through my function generator, and that's crazy. Okay. And run it on the oscilloscope. This is currently unloaded, as you can see. This is my output, just no resistance right here to ground. So my voltage in peak to peak right here is going to be 1.005 volts. And then our voltage out, this blue graph right here, voltage peak to peak, unloaded is about 18.8, we'll say, millivolts. Now adding this resistor in between voltage out and ground. You can see the voltage change a little bit there. Went up to about 23.8 millivolts. There we go. And number 4, or 5, I think I deleted the number on that one. Number 5, calculate the unloaded voltage gain. It is V out over V in, which is 0.188 over V in, which is 1.005. Pulling up a calculator real quick. That is 1.005. 0.187 volts. And for the loaded voltage gain, again, V out over V in. This one's going to be 0.238238, I mean, over 1.005 V in, which is equal to about 0.237 volts, or 2.37 millivolts, but we'll just do it in volts so we can calculate the output impedance, which is going to be, so I'll say ZO is the output impedance, which is going to be equal to the load resistance times V minus the load voltage, all of that over the load voltage. There we go. So that is going to be equal to 5.8 K times voltage in, which is 0. Sorry, this is the unloaded voltage, 0.187 minus the load voltage, which is 0.237. All of that over the load voltage, 0.237. And instead of K, I'll do times 10 to the 4, just to make it easier. So the output impedance is going to be 0.187 minus 0.237 times 5,800 for the load resistance, all that over 0.237, which is 1,223.6 ohm, or 1.223 kilo ohm. All right, thank you.